Welcome back, class. Today we'll take a look at shell scripting, Regex, and two parsing tools, sed and nom. We're also going to take a look at the project that you're expected to complete this semester. So we'll kick off talking about the shell language. Shell programming is one of the most powerful features on any Unix system. If you cannot find an existing utility to accomplish the task you're trying to do on the system, you can likely build one using a shell script. Like most high-level languages, shell programming features variables, control structures such as loops and if and else statements, and functions. But where shell differs from most languages is that it can call Unix commands directly. Now, Python and a lot of other languages can also call these commands, but it's not as intuitive. Whereas in Bash and a lot of the other shells, you can just call them directly. And this is a very powerful feature that doesn't jump out right away, but we'll see why it does in a few minutes. So just starting off, here are some things to remember when you name shell scripts. We want to give things meaningful names, such as here we got findfile.csh. Don't use script1 and script2, and do not use the Unix command names, because those are already saved in the path. Generally, you should also create a directory to store your shell script. For example, in my home directory, I keep a directory called bin that stores my shell script. Because I've exported ~bin to my path variable, the shell looks where to execute my program. We'll take a closer look at this in class tomorrow during the demo. A shell must be specified at the beginning of a script for the script to execute properly. So here we've got shebang/bin/bash/csh/tsh. So you've noticed there's several different kinds here. Now /sh is going to default to bash, but we also have CSH, we have TCSH, and I think on this box I'm running ZSH. So these are all, you have Z shell, C shell, bash. They're all different shells, and they vary a little bit differently. You can look this up and figure it out, but most Linux systems default to bash. It's what we're going to be working in this semester. So, and again, they're very similar. I'm going to execute a lot of my example code on Z shell, but everything I execute will be executable on bash as well. And so you're also going to have to pay attention to the permissions on your script. And these can be changed using the chmod command or change mode command. And again, we'll check that out in demo. For formatting, you should group commands based on task. So if three different commands parse out telephone numbers, then group those three together and add a comment. Comments begin with a number or pound sign at the beginning of each line. So to review the steps, use good names for your scripts. This includes variable names. Use comments to discern what the script does, as well as break down the function of different parts of the program, and use indentation and grouping to reflect the logic of the program. So here we have an example script. You can see we've got shebang/bin/bash, so this is going to be a bash shell that executes this. We have echo, which is a command, and that just tells the shell to return whatever follows onto the display. Then we have hello, which is just a string, and then inside this we have $user, which is actually a shell variable. Or actually it's an environment variable, and it will return the username. So whenever you see this ran on the shell, you'll get hello and then whoever the user is. Then we have echo this machine, uname tac in, which is going to return some information about the system itself, the calendar for this month, and the processes you're running. But as you can see, Right here they have cal and ps. These are just commands like echo that are just going to run. And this is, again, where it's very powerful. If you were to try and run this out of Python or something else, you'd have to add a little bit more. So this is just a much quicker way to get things, a lot of functionality out of the system. So there's two types of variables. Environment, which are valid for a complete login session and are uppercase by convention, and then regular shell variables, which are valid for the shell invocation or execution of that shell script. So going back to this, when we execute this, we actually don't set any variables in this script, but if we were to set a variable here, which you'll see how we do that later, it would only be valid while this script was running, if it's a shell variable. Whereas environment variables are for the whole session. And the shell variables are lowercase by convention. So here's a list of some of the predefined variables that we'll find. Again, we're going to take a look at this stuff in demo. You can read through this. Looking at the shell syntax, we can see that it resembles Python in some ways. There are no data types that need to be declared on variables. So you can see we've got an example here where rate equals 7.65, and then you say var name equals value, so you can set that to any value. You can set it to a string. We got that down there at the bottom, so name equals Thomas William Flowers. It's very similar to Python in that respect, that you don't actually have to put data types on these. But if you're going to do numeric or arithmetic on the variables, generally we use let if we're going to set the variable directly. Now there's actually several ways to do this. We wouldn't have to use let. We could say count equals 1 and then use some different commands to do arithmetic. But if you just want to type it in, like plus 20, you should use let to set the variables for numeric value. To delete a variable, you can use unset, though if it is in a script, it will be destroyed regardless at the end of the script execution. But if you can use variables in the shell environment without actually running a script. So we can set variables while running just regular shell commands if we want to use that variable for something, and then we can unset it later. For constant variables, you can use the read-only before a variable. And then if you run set, you can actually see all shell variables. And again, we'll cover this in demo. So this is it for shell scripting. You need to check out some of these links that I have here. They kind of go into the more complex details of it. Again, we're going to run a pretty good demo tomorrow, and we're going to go over everything that you just saw. So now we're going to shift gears here. Alright, so we're going to talk about regex. So, a regular expression is a special text string for describing a search pattern. Think of regular expressions as wildcards on steroids. Wildcard notation, such as star.txt, finds all text files in a directory. The regex equivalent is caret.star/.text $. Clearly, the wildcard looks faster, but the regex expression is much more powerful. While in this case, it is probably faster to just use the star wildcard to find any .text file we're looking for. If we had another query that, say, needed to have .text with the string user in the name, this is where regex excels, which we'll see in a few. So let's take a look at what makes up a regex expression. The first thing to note is that any non-meta character matches itself. So a lowercase a character matches, you guessed it, a lowercase a character. An uppercase version matches the uppercase a, and so on. So now for the meta character. So, like I said, the A's numbers, anything that basically isn't on this chart and a couple other charts that we're going to see are going to match themselves. But here we actually have a dot character which is going to match any character, but only one of them, except for the new line character. And we're actually going to go into this stuff in detail, so just keep this slide. Again, we'll cover it in demo and you can use this, but we're going to break all these meta characters down. Alright, so we're going to talk a little bit about the grep utility as it uses regex. So here we have the grep command, which searches for text in files or a set of files. So we can see in the example that the structure is command, expression, and then file. So we have grep root mail.log. That's going to search for the string root in mail.log. Now, if we look all the way at the bottom one, we can see a wildcard here at grep, or the second one from the bottom, RO star T. So that's using a normal wildcard. And then the last one's actually using a regex expression with a wildcard. So here are more meta characters. Again, we're going to kind of dig into these and what they do, and we'll be demoing them and working through them together tomorrow. But this slide's here for your reference. Okay, so breaking down a regular expression. To build a regular expression, we have atoms and operators. The atoms are what text is to be matched and where it is to be found. And the operator combines regular expression atoms. Here are the common atoms you will see in regex. We'll look at these individually next. So again, single character. Now we got the single character atom. For the single character atom, we can see that it matches itself. This slide also shows the order of operation for regex. If the regex is just the character L, then it will start at the front of the string to be searched and check itself against each character. So you can see the L starts at H, goes to E, and then it hits an L and it returns a true. Now it's something to note that regex by default only returns true or false if it found a match or not. The way we use it is to actually search for things. So it's actually side effects of programs like grep that we get the return. But at the base level, it's actually just returning a true or false. Now, again, when we use it, we're going to actually see any line that matches what we're searching for. So if we look at the S here, it's actually going to run through all of these letters. It doesn't match any of them, and it's going to move on. Return a false. So looking at this, we got our dot, the dot atom. This matches, the dot atom matches any single character except for the new line character. So you see in the first example, the single character dot matches H because that is a character, returns a true. Here we have capital H dot. So what that's going to look for is a capital H first, and it finds that. And then it's going to look for any character attached to that sequence. And so there is a character attached to that sequence and it returns true. And we can see the little h, there is no little h with a following character attached to it. So it returns false. Now the class atom is where we start to see the power of regex. The class atom will match one character with any of the characters defined in the set. So here we see the set of characters in this example is ABL. And what that's going to do is compare that character H to any character in that set and match it, but only one character. So it says H, is that equal to A? No. B? No. L? No. And then it moves on to the next character. E, and then it moves on to the next character. A, B, L. And it matches an L. So we get a return of true. Now it should be noted that it's going to match the first thing it finds. So if there was an A at the beginning of this, it would always match the A and never get to the L. Here are some different ways to use the class atom. Note the A, or the uppercase A to Z, lowercase A to Z on the right there, where it says any alphabetic. And also note the 0 to 9, where it says any digit. This is the way that you would actually try and match any character that is in the alphabet and then any digit as well. So these are some of the powerful things you can see start to pop up with Regex. Again, I know this may seem a little confusing right now, but we're going to have a shell running tomorrow and run through all of this. All right, so now we'll talk about anchors. They tell the next character in the pattern. Excuse me, I said that wrong. Anchors tell where the next character in the pattern must be located. So we have the anchor caret, it says at the beginning of the line. So what that's saying is that whatever follows the caret in the regex expression, so caret A would return false on this string that we have to the right, one line of text. And the reason it would is because we have the caret, which is the beginning of the line, and then it would find an O in that place. And so we would get a mismatch. But if we had caret O in the regex expression, we'd actually get an O, or it would return true. So then we have the $, which is actually for the end of the line. So caret's the beginning of the line, $, is the end of the line, and it's going to look at the character at the end of the line. And then we have beginning of the word and end of the word. These are still used quite often, but a little less than the other two up top. But that's going to be / less than and / greater than. And it'll search the beginning of every word or the end of every word for whatever character is next. Sequence operators are just a sequence of characters, not contained in the set brackets. So dog without brackets around it. Dog with brackets around it would search for D, O, and G on one character. Dog with no brackets is actually going to search for the string dog. So, like you would expect, if you want the string user from our earlier example, we would actually type out user. Now we'll look at the alternation operator. This operator is essentially an OR operator. So here you can see in our example we have Unix and Unix, one uppercase, one lowercase. This is going to look for Unix or Unix. So it's going to look for the uppercase version of it or the lowercase version. It's not going to mix and match. It's actually looking for just a fully uppercase or a fully lowercase version of that string. Same for the bottom one. The repetition operator matches the previous character m to n times. So here, taking a look at A, we have A, and it's going to look for A up, starting at 3 matching A's, or 3 sequential A's, up to 5 sequential A's. So you can see on the right, matches all those A's. Now take a look at BA, and it's going to match 3 to 5 as well, but it's going to match 3 to 5 on just the preceding character, just the A, not BA. It's not looking for BA, BA, BA. Okay, it's actually going to look for B, and then 3 A's, B, then 4 A's, and B, then 5 A's. Here are some common repetition forms to take a look at. And you can see from the examples what exactly they do. Here are some short form repetition operators. We have star, which is for 0 or more cases on a match. The plus sign, which is for 1 or more times. And the question mark, which is for 0 or 1 time only. So the star is going to match 0 or more A's that it finds. So on the first example there, you can see it'll match on a B because it doesn't need to find an A. It can be 0 or more. And then the plus. Okay, so down second from the top, we have the plus anchor, and so that's going to look for any character one or more times. I'll go over that in demo. They don't actually have a good example here. And then the question mark is basically, it's 0 or 1 digit. It doesn't really make it clear what that means, but what it means is that with this on the end of a string, let's say, that we're searching for, it's saying that a digit between 0 and 9 could be on the end of this string, or it may not be. So it'll match if we had our original example, .txt, and then with this on the end of it, and we were searching for that, it would find every text file, and it would find every text file that actually had a digit right after the .txt. Grouping allows you to apply an operator to a group of characters. So you can actually jump down. You see our repeat, or right there for the A, B, C. So we group B, C together. I told you that the repetition operator, the braces 3 brace, that would only apply to the preceding character. But if we group it, it will now look for 3 B, C, B, C, B, C. Whereas if we didn't group this, it just said A, B, C, then with the brace 3 brace, we would actually see 3 C's is what I would look for. Okay, so that was quick. Probably really confusing. Again, I just want you to hear this stuff, see it, know what those words mean, and then when we get in class tomorrow, we're all going to jump on the computers and actually test this stuff out. All right, so now we're going to take a look at the project. So the objective here is to give students the opportunity to practice using software development methods and tools. We're actually going to go 6 students per team. I'm going to be going over this the first day, so y'all probably already know a lot of what you're going to be looking at. We'll also touch on this the second day just to make sure everything's understood, and I'll be putting out some forums online as well. It says from the same lab section, you're all in the same lab section, so we don't have a problem there. And then we're going to determine the team composition on Piazza. So the requirements for our project are you need a working software application. This includes a front end, back end, and a database. Documentation of all of the development process. Use of repository for all deliverables. We'll be using Git or GitHub. Milestones are going to be the evidence of progress along the way. Each milestone has a specific requirement, deliverables. Obviously, you're going to work as a team and follow a methodology, which I'll set you guys straight on what all this means throughout the course, but more particularly with a full design document. As far as the grading goes, a working software application will definitely get you a good grade in this class. One that doesn't, won't. So this needs to include a front end, a back end, and a database that is functional. Again, documentation so that we can see the process and see it growing slowly, not just all done right at the end. Now, this is a 5-week class. It's going to happen quick, but again, I'm going to go over you with the pacing that you guys need to keep. For the milestones, this is the evidence of progress along the way. We've got 6 of those. They'll be submitted and graded as a team, and they're adjusted based on the peer evaluations. That says number 8, but it's really number 7. It's kind of not included in these 6 milestones, but that will help adjust your grade, is how much your peers think that you contributed to this, as well as we're going to be watching GitHub commits. So it's important that everyone is contributing in some way. And so here we can see the breakdown of the milestones that we're going to have. Basically everything gets 40 points across the board except for the final report. This is subject to change, and we may actually not do a milestone 4 or do a different milestone 4. So we'll talk about that as we get closer to unit testing and integration testing. But I'll let you guys know and keep you updated on that. Okay, so now we're going to talk a little bit about awk. So awk is a programming language designed for text processing. It's used for processing regular expressions in a script. It's used when the text is in a file delimited field format. And it typically is used as a data extraction or reporting tool. Powerful standard feature of most Unix-like operating systems. Excuse me. So, looking at awk operations, how it breaks down, this actually scans a file line by line, splits each input line into fields, compares the input line fields to the pattern that is put into awk, and then performs whatever actions have been stated on those matched lines. It's useful for transforming data files and producing formatted reports. It does include programming constructs. You can format output lines for reports. It's got arithmetic and string operations as well as conditionals and loops. Okay, so awk consists of patterns and actions. If a pattern is missing, the action is applied to all the lines that match. Or excuse me, if a pattern is missing, the action is applied to all lines, period, because there is no pattern to match. If the action is missing, then the matched lines are printed to the display. If both are missing, then nothing happens. You must have one of these, either a pattern or action, to actually get anything to happen. So here we have a basic awk command with just a pattern. Its output will be all the lines containing the string 4 in the user file test, or in the file test file. All right. So there's some basic terminology surrounding awk. A field is a unit of data in a line. Each field is separated from the other fields by the field separator or the delimiter. The default separator is white space, but it can be colons, commas, anything, and these can be changed as needed. A record is the collection of fields in a line. It is essentially the line. And then a data file is made up of records. So, here's what the file looks like. This is what awk works best on. As I said, the records are basically lines. You can see on the left there, it's pointing to 2, which is mark equals 6.2540. So that line is the record. Then we have the fields. So we got field 1, 2, 3, 4. And so you can see how this breaks down. There are default buffers in awk for quick access. There is a record buffer, which holds the whole record or line. And then there are field buffers, which hold each field. So the record buffer by default, or the record buffer is $0, and that will actually print out the current line that we're dealing with, or the current record. And then you have $1, 2, and so on up to N, which are the fields that have been delimited either on white space or on some other delimiter. So here we have some system variables that awk can use. The field separator, default white space. The record separator, default /n, hence the line. Now note, this could be changed to something else as opposed to /n. Then we have the number of fields for the current record, the number of the current record, the output field separator, output record separator, and the file name, or the current file name. So we're going to take a look at these things more in depth, but here is just a quick example. So we have awk, which is our command, and then it's given this action. And so it's going to do it to all of them because we haven't given it a pattern. We'll see how patterns are put into awk in a minute. So here's the action, and it says print the record number. And so we can see on the left there we have 1, 2, 3, 4, whereas before when we just catted the EMPs, we didn't have any numbers in it. So that's the record number. And then it says print the record, which again I told you is delimited on new line, so that's the line, so we see the whole line after it. In this example, our fields are separated by a colon. So in our command, we will use the tach F followed by the delimiter we want to separate our fields on. In this case, it is a colon. This command says separate on colons and look for Jones. That's the pattern contained in the forward slashes. And then print the first and second record from the file em2. Sorry, I said the first and second record, the first and second field. So again, it's going to delimit it on the colons. It's going to look for the word Jones on any of the lines. It's going to find a match on one of them, and then it's going to apply this action, which is print the first two fields. Notice the first field is the name, and the second field is the four-letter digit. In this example, we see that in the pattern we are using regex. This will match any line with two sequential zeros at the end of the line. Okay, so remember, this is where you start to see regex being applied. In those forward slashes, we have our regex expression. So we have 0, 0, which is just a sequential numbers, and those are digits, so they'll match themselves. And then we have the $, which says at the end of the line. And so again, it's going to find the ones with the 0, 0 on the end of the line and match. Here's an explicit match example. Let's break it down. In the command, we can see that we have $5. This is the awk field buffer for field 5. So the decimal numbers, so that's the decimal numbers. We count over 1, 2, 3, 4, 5. That gets us to the 0.98 and all the decimal numbers there. The tilde means match explicitly whatever pattern is to the right. So we have the $5 there on the awk command, and then a tilde, and then that's saying match field 5 with whatever is in those forward slashes. In the regex, so let's take a look at that expression, which is located between the, I said forward slashes, excuse me, backslashes. We have a /. So what this does is actually going to escape the dot. Because remember, dot in regex means something. It means any character, right? And so we need it to mean dot. We need it to mean just a period. So we can escape it with a /, and then we follow it with the brackets 7 and 9. So that's going to look for the digits 7 and 9. And then that's followed by the plus sign, which means one or more times. So it's going to look for dot, a number between 7 and 9, one or more times. And actually, I'm pretty sure that if we were to run this, which we'll see in demo tomorrow, I'm going to run this command for us, and I'm pretty sure it's going to match all of those, not just the ones that are listed there. So here's some more reading for awk. I would suggest you use it. It's a really powerful language, really great. Now we'll look at sed. This is going to be real quick. So sed is a programming language designed for text processing, just like awk. Used for processing regular expressions in a script. It's used when the text is in a stream, so no delimited field structure. Typically used as a stream editor. That's the name, stream editor, sed. And it's a powerful standard feature of most Unix-like operating systems. So just to jump on this real quick, so the awk versus sed, awk is used on field delimited things, and sed is used on just like a normal README file or something like this, just a bunch of strings, okay? But they're very similar in operation. So here's our operations. It's going to loop through a file line by line. It looks for the text patterns, execute commands on match, substitute, delete, insert a new line. Useful for transforming data files, finding text in strings and changing them. And it does have, it's actually a little more primitive than awk. It's not as powerful. And then we have some more tutorials and reading that you should check out. So that's the end of lecture 2. It's pretty straightforward, pretty quick. So the thing is we are going to be demoing a lot of this. Again, I know this probably was just really confusing sounding, but we're going to be looking at all this in class tomorrow. And now that you've heard it, and I'm pulling everything up and talking about it, hopefully this will make a little more sense once we get it running in the terminal. All right, see you guys tomorrow.